The optical emitter can also protect sensitive light detectors from harmful laser radiation.
Hello, welcome to yet another episode of SimplyPHY. Did you know about goggles which can protect your eyes from harmful laser radiation? Then let me take you one of the labs here at RRI. Here, scientists and their collaborators have proposed a material which can be used to make this goggles. Let's hear them.
The optical emitter is normally a transparent material, but when a powerful laser beam falls on it, the emitter will become immediately opaque. So if you can make a goggle making use of an optical emitter, then that's very useful for you when you are working with laser beams. So in this study, we used an interesting material called Hematene, and we measured the optical emitting efficiency of this material.
Hematite is one of the natural ores of iron. It is a non-van der Waals material abundant in Australia, Brazil, China, India, and Russia. For this experiment, bulk hematite powder was obtained directly from the natural ore collected at Bellary. Since hematite in the powder form is used in the exfoliation process, the nanoflake formation is much faster compared to the earlier version. The supernatant containing smaller nanoflakes is collected and used for characterization and also for measuring the nonlinear optical properties.
So what we do here is that for making this measurement, we use something called an Nd:YAG laser, which is a pulse laser, and it produces very short laser pulses of about only 5 nanosecond pulse width at green color. So we focus these laser beams and then we send the laser beam into the sample and we increase the intensity of the laser pulses by a particular experimental setup called the C-scan experimental setup. What we have noticed is that when we send the laser pulses through this medium, through the Hematene medium, and when we increase the intensity of the laser pulses, it becomes more and more opaque, or the transmission of the medium to the laser pulses becomes less and less. So this is how the optical emitter behaves. In the normal case, it is very transparent. So many optical emitter materials which people have studied in the past are not that transparent in the normal case. So what happens is you have to start with a material which has some absorption to begin with. Sometimes this is quite some absorption, like let us say some 30% of the light is absorbed to begin with. And then when you put a laser beam onto that, it becomes somewhat opaque. Compared to that, this material Hematene gave us something like 87% transmission. That is, for all practical purposes, it's a very, very transparent material to begin with. But when you put the laser light onto it, it becomes pretty opaque. So that is the speciality of this material. We get both things good. That is, normally it's very transparent, and when we put the laser beam onto it, it is pretty opaque also. It's a potentially good material for making optical emitting devices which can protect human eyes and also sensitive optical detectors from harmful laser radiation.